Come on students, all of you say the boiling point of water is 100 degrees Celsius. Hey there, Joel here and welcome to my channel Math World. Today is the part 2 video of understanding the change of state of matter, and we are going to concentrate more on the boiling point. Okay, and this is a question for you. Does water always boil at 100 degrees Celsius as the way all the teachers used to tell us? No, all I want you to do is, till I roll that intro, you can write down in the comment section whether it is true or false. Okay, boiling point of water is 100 degrees. Is it true or false? Let's roll the intro. I hope you have already commented in the comment box. So now let us understand what do we mean by boiling point. And it sounds simple, right? Boiling point. So the temperature, the point at which a liquid will start boiling will be called as a boiling point. And I have experienced students also writing this as the answer if it is asked in the question paper. But nevertheless, it is not incorrect. It is partly correct. Okay, so what is boiling point? The temperature at which a liquid will change its state, alright, at atmospheric pressure is called as boiling point. Okay, the actual definition is there on the textbook. Please go ahead and read the textbook so that these definitions are very clear. I always concentrate more on the understanding part rather than the by-hearting part. So I'm telling you, please get these definitions understood from here and learn from the textbook. Okay, so in this entire statement that I've just said, you will realize that there are 2 points or 2 words which are very important. One is the temperature part and the other one is pressure. Okay, and even in the previous video there was a term as atmospheric pressure. So what has pressure to do with change of state? Before I explain you that, you need to understand what exactly is pressure. So let me give you a simple example. Okay, say for example you are standing, okay, and I give 1 kg of weight on your head because you're holding it. Then I put another 1 kg. So now there's a little extra weight on your head. Then I put another kg on top. So like this, I put 10 kg of weight. Okay. So now there is a lot of pain that you are experiencing on your head. Correct? If I start removing the weights that are there, you will feel lighter. Okay. So basically now there's no weight actually on top of your head, but there is a air blanket that is there, because when you are standing on the earth, the entire earth for kilometers and above, there is air blanket that is there. So that much of weight of air is exactly on you. That will be called as atmospheric pressure. Okay, now if I say, okay, we are digging a well and then there's a big trench or deep down we are digging it, right? So I take you down there. So now from this level you are down here, okay, and you're standing at this point. When you're standing over here, again the amount of air that is there above you has increased, right? So that means I can say that the pressure on your head is becoming more because you are at a lower level. What if I tell you you are moving on to a mountain? So now from this point, this is normal level which was there, now you have moved higher. Okay, so this much of distance of air that would be above you is reduced now because you have moved higher. The air that is above you is lesser. I hope this part is getting clear. So as you move higher, the atmospheric pressure will reduce because that weight of air on your head is reducing. That's the idea of pressure. Okay, so what it has to do with regards to boiling? No, in a normal scenario, if I would, put a burner over here, keep a beaker and put water in it and I keep it to boil. First, as the temperature is increasing, remember in the previous video, the bonds are breaking. Same. So in that liquid, the bonds are trying to be separated. The bond is broken. Okay. The moment the bond is broken in the liquid, the particles are ready to move out from that bond and go away. It is just like, you are in a class and there is no teacher. All you want to do is run away, go out and come back, right? So here the particles are moving. Now at a normal pressure, there's always this pressure which is trying to push those particles down and keep them. Okay, and this side there is heat given. Now this heat is breaking the bond. Now there is one particle, okay, always find a sharpener. Okay, so there is this particle, this is the exact surface, okay, of the liquid, okay, the top surface. So this particle has gained that much of heat energy now and it wants to move away from this and go up as steam. So this particle is all set to move. The moment the pressure on this particle is same as the pressure of the air, this particle will go. So now what happens is, if I would perform this same experiment going on a mountain, okay, then the heat supplied is the same, water is also from the same source. The only thing that is changing is the pressure, because as you have moved at a higher point, the pressure, air pressure that is there is lesser. So what is happening now? Again, heat is received, this particle is all set to move out. When it will go, it will move out from this water content, the water group from there, only when the pressure on this particle is same as the atmospheric pressure of the air over there, okay, in that environment. So since there is less pressure as you go higher, this particle is all set to move out. It is like, here above on the mountain, you have a teacher who is not strict and is very relaxed and gives you all the freedom to do all the mischief possible. So these particles are too excited to move away at a very initial stage. But if at a ground level, in a normal scenario where we are at sea level, this pressure, the teacher you can consider is a strict one, will not allow you to move this side or that side. So these particles are, all ready to move out, but the teacher is, or rather the pressure is holding it together. The moment they get that feeling that this teacher is going out from the class, they're ready to move out from here. I hope this idea is clear. So basically, if you want to boil water on Mount Everest where the pressure is way low, you will realize that water will not boil at 100 degrees. It will boil somewhere between 50 to 60 or 65 degrees Celsius. So if next time your question is asked about water boil, the boiling point of water is dash, and if you write 67 or 65 these degrees, it is practically possible. So you can ask the teacher, unless it is mentioned at atmospheric pressure. Okay, so that is important. The moment you give the pressure to it, then we are talking about 100 degrees. But if it is not given, then water can boil at any level. There are experiments done to take it to a point where the pressure is almost close to zero. That means you're doing it in vacuum and trying to understand what actually happens to water. You can check out some videos after you're done watching this video and gain a little more insight about this. So I just thought of sharing this with you. This part is not there on the textbook telling you about what is the temperature at which water will boil, but I felt you should know it because it's something very interesting that we've always been hearing that water boils at 100 degrees, but need not be. Okay, now you know the idea. Higher, as you go higher, the pressure is lower. Okay, and because the particles will move away from the liquid state to gaseous state only when the pressure of those particles which are ready to move is equivalent to the pressure of air. Okay, so the moment that both of them are at the same level, that's the time these particles will move. I hope this is clear, and if you understood this video, then don't forget to hit the like button, share the video with your friends, and subscribe to the channel. Till then, Joel saying bye to you. Ta-da.